Let's start with a new chapter, integration by parts, part 2. Last time when we saw integration by parts, it was without substitution. Here we will see integration by parts with substitution. This is parts using substitution. Right, let's start. Integral of cos x log mod sin x dx. Right? As we saw in the last lecture, we don't have a formula for log function. So you will say let sin x be equal to t. Differentiate with respect to x. So you will get d by dx of sin x is dt by dx. Therefore cos x is dt by dx. Therefore dx is dt upon cos x. I can say I is integral of cos x log t. Dx can be written as dt upon cos x. So you will get integral of log t dt. We do not have a formula for log function. So this will be log t into 1 dt. Log t1 can be written as t raised to 0 dt. Now you can use parts uv. This is going to be log function will be u, t raised to 0 will be v. uv is v integral of u minus integral of u derivative of v. This can be written as log t, integral of t raised to 0 is t, integral of t raised to 0 is t, d by dt of log t is 1 upon t dt. This can be written as t log t minus integral of dt. This is t log t minus t plus c. Substitute the value of t, the value of t is sin x. So this is sin x log sin x minus sin x plus c. I would take sin x common here. Log sin x minus 1 plus c. That will be your answer. Let's move on to the next one, guys. Integral of sin root x dx. Let's see how do we do the sum. You will say let root x be equal to t. So in that case you will say differentiate with respect to x. D by dx of root x is 1 upon 2 root x is dt by dx. Therefore you can say that dx is dt upon 2 root x. I can say I is integral of sine root x can be written as t, dt can be written as dx can be written as dt upon 2 root x, right? This is wait, give me a sec. So in that case you will get dx is 2 root x dt. You just make that correction here. So I can say I is integral of sine root x dx. So this can be written as integral of sine t. Dx can be written as 2 root x dt. This can be written as two constants sine t. Root x can be written as t dt. Here you have two functions, multiplication of two functions. So therefore you can use parts here. Let this is algebraic, this is trigo. Algebraic comes before trigo. So algebraic term will be the u term. So u integral of v minus integral of v derivative of u dt. This can be written as 2t. Integral of sin t is minus cos t minus integral of sin t is minus cos t d by dt of t is 1 dt. This is 2 minus t cos t. Integral of cos t is nothing but sin t plus c. This can be written as 2 minus t. T can be written as root x, cos root x plus sin root x plus c. Let's see another sum, guys. Integral of log x the whole square with respect to x. Now you will say let log x be equal to t, differentiate with respect to x. So d by dx of log x is 1 upon x is nothing but dt by dx. Therefore dx is x dt. Now let's understand the concept, guys. When I say log x is equal to t, that means I mean to say that log x to the base e is equal to t. As log x, when nothing is given, you assume the base to be e is equal to t. Now if I use first principle of log, I can therefore say that x is equal to e raised to t. You can say that x is equal to e raised to t. Now let's see this. I is integral of log x the whole square dt. Integral of log x can be written as t square. Dx can be written as e raised to t dt. Here you can use parts uv. Now this is going to be algebraic, this is going to be exponential. So u integral of v minus integral of v derivative of u right. So now this can be written as t square. Integral of e raised to t is e raised to t minus integral of e raised to t is e raised to t. D by dt of t square is 2t dt. This is going to be t square e raised to t minus 2 comes out t e raised to t dt. Right. Now you can apply paths here again. We'll continue this up. This can be written as t square e raised to t minus 2. Apply paths to it again. So t will be u and e raised to t will be v. So u integral of v minus integral of v derivative of u dt. So this is t square e raised to t minus 2t. Integral of e raised to t is nothing but e raised to t. Integral of e raised to t is e raised to t. D by dt of t is 1 dt. This is t square e raised to t minus 2 t e raised to t minus integral of e raised to t is e raised to t plus c. Here t can be substituted as log x. So this is log x the whole square. E raised to t can be substituted as x minus 2. Here I could take e raised to t common, so I'll get t minus 1 plus c. Substitute, so this is x log x the whole square minus 2x log x minus 1 plus c. Fine, that will be your answer for this one. Let's move on to the next sum, guys. Integral of tan inverse of root x dx. Fine. Now you will say let root x be equal to t. Differentiate with respect to x. D by dx of root x is 1 upon 2 root x is dt by dx. In which case you will get dx is 2 root x dt. I can say I is integral of tan inverse root x can be written as t, dx can be written as 2 root x dt. 2 comes out. This is nothing but integral of tan inverse of t root x can be written as t dt. Use paths inverse algebraic. Inverse comes before algebraic. So this is 2. So this will be u, this will be v, rate, right? So u integral of v minus integral of v derivative of u dt. This is 2 tan inverse of t. Integral of t is nothing but t square by 2 minus integral of t is t square by 2. d by dt of t is 1 upon 1 plus t square dt. This can be written as 2 t square tan inverse of t by 2 minus 1 by 2 integral of t square upon t square plus 1 dt. The degree of polynomial is same in the numerator and denominator. Since the degree of polynomial is same in the numerator and denominator, therefore you will introduce the denominator in the numerator. Add 1, subtract 1. That way you can introduce the denominator in the numerator. Fine. Let's see this. This can be written as 2 t square tan inverse of t upon 2 minus 1 upon 2. Split the integral sign, so this will be integral of t square plus 1 upon t square plus 1 dt minus integral of 1 upon t square plus 1 dt. Right? This can be written as 2 t square tan inverse of t upon 2 minus 1 upon 2 integral of dt minus integral of 1 upon t square plus 1 dt. This is 2 t square tan inverse of t by 2 minus 1 by 2. Integral of dt is t minus integral of 1 upon t square plus 1 is nothing but tan inverse of t plus c. This can be written as, substitute the values, 2 t can be written as root x. So this is going to be root x the whole square, that is x tan inverse of root x upon 2 minus 1 upon 2. This is root x minus tan inverse of root x plus c. Open the brackets. So 2 and 2 gets cancelled. So this is x tan inverse of root x. This 2 and this 2 also gets cancelled. Plus into minus, minus root x. Minus into minus plus tan inverse of root x plus c. That will be your answer. Let's move on ahead, guys. Integral of x upon 1 plus 2x dx. Right? Now here 1 plus cos 2x dx. Right? Let's see the sum. Now this can be written as integral of x upon 1 plus cos 2x. 1 plus cos 2x by using multiple submultiple is nothing but 2 cos square x dx. 1 plus cos 2x is nothing but 2 cos square x by using multiple angles. This can be written as 1 upon 2 integral of x cos square x. 1 upon cos square x can be written as sec square x dx. Fine, do we get this thing clear? Now, this can be written as 1 upon 2 integral of x. Now we know that d by dx of tan x is nothing but sec square x. So sec square x can be written as d by dx of tan x dx. Right? Now apply UV. Paths. Whenever you have a term and another term is a derivative, then the derivative term is always v. So this is going to be u integral of v minus integral of v derivative of u dx. 1 upon 2 x. Integration and derivative cancel each other, so this is tan x minus integral. Integration and derivative cancel each other, so this is tan x. d by dx of x is 1 dx. This can be written as 1 by 2 x tan x minus integral of tan x can be written as sin x upon cos x dx. Now d by dx of cos x is nothing but minus sin x. I am going to make the term in the numerator to be the derivative of the term in the denominator. D by dx of cos x is minus sin x. So what I am going to do is, this is x tan x minus integral of sin x upon cos x dx. Take the minus sign inside, so this becomes plus, this becomes minus. I am taking the minus sign inside. Okay. Now the term in the numerator is derivative of the term in the denominator. So this is going to be x tan x plus log mod cos x plus c, and we answer. Let's see another sum. Integral of x 1 plus sin x dx. Right? Let's see the sum. Now we do not have a multiple or submultiple formula for 1 plus sin x. So what we are going to do is rationalize. We are going to rationalize the denominator. So if I rationalize the denominator, it is 1 minus sin x upon 1 minus sin x dx. This can be written as integral of x minus x sin x upon 1 minus sin x. 1 plus sin x is 1 minus sin square x, which is cos square x dx. This can be written as split the integral sin x upon cos square x dx minus x sin x upon cos square x dx. I am splitting the numerator and integral sign simultaneously here. This can be written as integral of x sec square x dx. 1 upon cos is nothing but sec square x. Sin x upon cos x is tan x. 1 upon cos x is sec x dx. This can be written as integral of x d. We know that d by dx of tan x is sec square x. So sec square x can be written as d by dx of tan x dx x. We know that d by dx of sec x is sec x tan x. So sec x tan x can be written as d by dx of sec x dx. Now apply paths for both the terms. So this is going to be, this term is u, this term is v. So u integral of v minus integral of v derivative of u dx. minus this term u integral of v minus integral of v derivative of u dx, right? So I'm using parts twice here. Now this can be done as x integration and derivative cancel each other. So x tan x minus integral of integration and derivative cancel each other, tan x dy dx of x is 1 dx minus x integration and derivative cancel each other, so this is going to be sec x minus into minus plus integral of integration and derivative cancel each other, so sec x dx, because dy dx of x is 1 x tan x minus integral of tan x, I just showed this to you in the previous sum, is nothing but I can write this as sin x upon cos x dx. dy dx of cos x is minus sin x. I get the minus sign inside and write the plus sign out here as it is, minus x sec x plus integral of sec x dx x tan x minus plus log mod cos x. You are using the formula integral of f bar of x upon f of x is log of f of x minus x sec x. Integral of sec x is log mod sec x plus tan x plus c, right? So that will be your answer. Let's move on to the next one, guys. Integral of e raised to x sin x dx, right? I is integral of, I'll just rearrange the terms and write them, multiplication, so you will have to use the uv formula, u integral of v minus integral of v derivative of u dx. This can be written as sin x, integral of e raised to x is e raised to x minus integral of e raised to x is e raised to x. dy dx of sin x is cos x dx. This can be written as e raised to x sin x minus uv again. So this is u integral of v minus integral of v derivative of u dx. This can be written as e raised to x sin x minus cos x. Integral of e raised to x is e raised to x minus integral of e raised to x is e raised to x. dy dx of cos x is minus sin x dx. Open the brackets and simplify. This is e raised to x sin x minus e raised to x cos x, minus into minus plus into minus integral of sin x e raised to x dx. But guys, let's look at the question. Sin x e raised to x dx, sin x e raised to x dx is nothing but I, so I can substitute sin x e raised to x dx as I. So this will be e raised to x sin x minus e raised to x cos x minus I. You already had an I on the left hand side. When I shift this minus I comes on this side will become plus I. So you will get 2I is e raised to x sin x minus cos x. I is e raised to x upon 2 sin x minus cos x plus c. Fine, that will be your answer. Let's move on to the next sum, guys. Last sum to finish this chapter. Integral of e raised to x sin x cos x dx. Now let's see this. I can say I is integral of e raised to x divide by 2 multiply by 2 sin x cos x dx. Right? This is 1 upon 2 integral of e raised to x 2 sin x cos x by multiple angle is nothing but sin 2x dx. So I'll get I is equal to this. Call this as equation 1 and leave this here. Now you will say let I1 be integral of sin 2x e raised to x dx. I'm leaving that half out and just doing the sum balance part of the sum. Here you can apply paths uv. This is u integral of v minus integral of v derivative of u dx. This can be written as sin 2x integral of e raised to x is e raised to x minus integral of e raised to x is e raised to x. D by dx of sin x is cos x, right? D by dx of sin u is cos u. D by dx of u dx. This is sin 2x e raised to x minus integral of e raised to x cos 2x. D by dx of 2x is 2, which is a constant which I am going to bring out here, dx. Now again I can apply paths. This is nothing but e raised to x sin 2x minus 2. Apply paths here. Cos x will be the u term, e raised to x will be the v term. So this is u integral of v minus integral of v derivative of u dx. This can be written as e raised to x sin 2x minus 2 cos 2x. Integral of e raised to x is nothing but e raised to x. Integral of e raised to x is e raised to x. D by dx of cos u is nothing but minus sin u d by dx of u. So that is d by dx of 2x, which will be 2 dx. Open the brackets. So this is e raised to x sin 2x minus 2 e raised to x cos 2x, minus into minus plus, minus into minus plus, plus into minus minus. 2 into 2 will give you 4. Integral of sin 2x e raised to x dx. But if you look at this equation, sin 2x e raised to x dx is nothing but I1, right? So you can therefore say that I1 is e raised to x common, sin 2x minus 2 cos 2x minus 4 I1, take plus c, we'll call this as say C1. Take the 4 I1 on this side, so you will get 5 I1 is e raised to x sin 2x minus 2 cos 2x plus C1. Take 5 in the denominator, so e raised to x upon 5 sin 2x minus 2 cos 2x plus c1 by 5. Substitute this in equation 1. Substitute this in equation 1. Can you please see equation 1? Equation 1 was I is equal to half integral of e raised to x sine 2x dx, which I had assumed as I1. So I can say substituting in equation 1, I'll get I is integral is equal to half I1, because integral of e raised to x sine 2x dx I had assumed as I1. Integral of e raised to x sine 2x dx I had assumed as I1. So this will become half I1, right? And we have just found out the value of I1. So this is half e raised to x upon 5 sine 2x minus 2 cos 2x plus c1 by 5. Now this can be written as e raised to x upon 10 sine 2x minus 2 cos 2x plus c, where we will assume that c is nothing but c1 upon 10. That will be your answer for this. This finishes this chapter. Thank you very much.